Hi, very good morning all. Thanks for joining the technical demo session of Advanced Performance Engineering. Today we're going to talk about one of the most critical part of the performance engineering. Okay, so it's all about the database performance degradation, especially the Oracle database that you have inside your infrastructure, which connects to many of the applications and understanding what happened inside your database, what are the ways to analyze the Oracle database, how to identify the performance problems, also understanding the different performance degradations, different performance problems that are caused by environment, that are caused by database, or how do we fix the performance on the Oracle database is what we are going to teach. Okay, and coming to the Oracle database, the first thing is if you ask me, do we need to install Oracle database? Yes, in order to have some kind of knowledge. I understand that many of the performance engineers who are actually um, involving in performance testing assignments, most of them, even me, for many years, I did not get access to the database. Even if it is a test database that sits on testing environment, for some reasons, okay, we may not get the access to the database server to take the AWR report, to take ASH report, to take ADDM report, just to understand. We really don't have access to understand what went wrong when a load test or stress test or endurance test is performed. Like I have explained yesterday, if you take any application, right, some percentage of the performance problems will happen from the client side. From 15 to 20% of the performance problems happen from the public web server. 25 to 30% of the problems happen from the application server. And all of the remaining 50% of the degradations, the only reason is the database server. Okay. So in order to understand what happened inside your database, you need to understand what are the different problems that you see in Oracle database. Okay. So can anyone of you tell me what are the different problems that you have experienced in any database, be it MySQL database, SQL Server database, or Oracle database, any database? Anyone?
A deadlock, long-running queries.
Most
Those are the common problems.
right. Most of the times it is deadlocks and long-running queries is also called. They are called high-load SQL statements. Okay, so I'm writing it for you. High-load
Our
SQL,
database connection pool size, if it is set low, then it can cause issue.
right? Connection pool is also a problem, right?
Yes.
Okay. So coming to the performance problems, so do you know why all these things are happening? You said some different problems, right? You have deadlocks, you have high load SQL statements. Let's say you have IO peak periods. Okay, you know why all these things are happening?
Maybe because database has not been optimized properly, or maybe some indexing issue.
Right, because of the first reason is because of bad application design that was implemented in the environment, or because of the bad application design that was created in the application will lead to all these problems. Like I said yesterday, no system is built perfect. No systems are perfect. Be it any, even if you take the on-prem, even if you take the cloud, public cloud, even if you are hosting applications on containerized, you're making the applications to sit on SQL databases, no SQL databases. Okay, and the Oracle cloud, Oracle on-premise, you may see a bit improvement in the performance with respect to response times, but at some point of time, when the transaction rate on the database server is increasing, which means there are SQL queries, PL SQL queries, stored procedures, which are being executed for millions of times in a day, at some point of time, it will create some sort of degradation on the database server. Okay, so if you have bad application design, it means that you have a bad schema, you have some changes in the application, or the teams have changed the application to the users, the way they use it, some changes in the Oracle database, or the changes that you do in the host configuration, all these things are the main reasons, key reasons in order to fix the performance. For example, if you want to fix the performance, we'll talk about that later. Okay. So in order to baseline the DB, first thing, if you want to understand what is happening inside your DB, you need to baseline the DB. Baselining the DB would require, okay, the first thing is you need to take the application statistics, application stats. Then the second thing is you need to take DB statistics. All these things are taken just to understand what is happening on the database with the minimal load. Okay, I'm sorry. So all these things are taken just to test the database with minimal load, and you have to understand what is the optimal performance of your database when it is being used with minimal user load. These are all the 5 things that are continuously taken each time to understand what is the minimum requirement. Okay, what is the minimum optimal load, what is the minimal behavior on the database. For example, when you're testing with 50 users or 100 users, you take all the application statistics, DB statistics, operating system statistics, and also disk IO statistics and network statistics. The reason is, as part of baselining and benchmarking, it is the first task that people will start looking at each of the layer, web app DB layers, from the client side and server side. They do a smoke test, which is also called pilot run, for 15 minutes with 5 users. Then they gradually increase the number of users. I mean, sometimes from the load testing side, when we run it, we also uh, count how many transactions were part of one particular script. Okay, when you run when you execute that script in Vugen, how much time it is taking with one iteration for all these transactions. So that is part of baselining and benchmarking. So you will slowly increase the load, and you will look at the database, and you'll also understand what happened inside the database. For example, I'll show you one doc. Okay, so architectural. Okay, before moving that, I'll show you the doc. So now, can any one of you tell me what are all the different bottlenecks that you faced so far, apart from deadlocks, high load SQL statements, connection pool, and high peak periods? If you differentiate the different bottlenecks that we see from the Oracle database, so what are all the bottlenecks that are caused from each of the different place of the database? Any idea on that?
Yeah, mostly if you are using rack load balancing related problems, if you are using the database in rack, load balancing the traffic to one database node to another database node. They actually have recently have come across this question in one of the interview.
Okay. So now we'll understand, I'm not asking you some of the basics, but we'll understand the difference between Oracle and Oracle RAC. If you look at the Oracle AWR report also, the first section, it will have the database details. After taking the AWR report, this is the first section you see in AWR report. Okay. So if you see the database details in the first section, you see the database name, the database ID, the instance name, the instance number, the startup time of the database, and the release, which is Oracle 11, and RAC, yes. Do you know what is the difference between Oracle RAC and normal Oracle?
No, I don't know.
Okay. Basically, Oracle RAC, it is going to allow multiple computers to run Oracle RDBMS software simultaneously, which means Oracle RAC will have multiple instances. Okay, in a non-RAC Oracle database, you will have a single instance which is accessing a single database. Okay, so you can have multiple instances of the database in Oracle Rack, whereas in non-Oracle database, a single instance accesses a single database. So in an Oracle Rack environment, 2 or more instances can concurrently access a single database. That is the only difference. Okay, like someone said just now, it is also the problem with the distribution of the load across multiple instances of the database, or if you have some 3 to 4 databases in your environment, when it is load balancing, you may see different problems. For example, load balance may not evenly distribute the load. Okay, for example, you have like you have 2 servers. Okay, this one is 57% utilized and this one is 57% utilized. And if you ask me which server 1 and server 2, which one is performing good, we may not derive the conclusion immediately, because you have metrics to each of the database server, and depending upon the type of uh, thresholds that you see with overall metrics on each of the server that you have inside your infrastructure, will tell you what went wrong. Okay, for example, you have 200 users load test running, you have 67% here, you have 57% here. Again, it means that it is again not it's not, we cannot directly say that the load is not evenly distributed across the database servers you have. Okay, so you need to carefully watch what are all the load balancing methods that are being used, what are all the load balancing algorithms that are in use. You have multiple types of load balancers like software balancer, hardware load balancer, you have network load balancers. So all these load balancers, and which is a different science, will work in different ways to, I mean, in order to evenly distribute the load across multiple instances that you have in your infrastructure. Okay, so uneven distribution of the load across the multiple servers can also be the problem. But there are few problems which are very, very important. I mean, when it comes to the database, when we talk about some of the crucial bottlenecks, the first thing I would like to explain you is the bottlenecks that are caused by environment. You know what are the bottlenecks that are caused by environment? Any idea?
CPU, memory, such kind of environment
Right.
means.
Right, you have a CPU bottlenecks. And again, many of the times, most of the people will ask you, what are all the reasons for high CPU high response times? What are all the reasons for high CPU utilization? Then your immediate answer should be, you should have a question, right? Are you referring to database server? Are you referring to application server? Or are you referring to web server? So when someone is asking, what are the reasons for high CPU utilization? Which server? Then I would say it is a database server. So there could be various reasons for high CPU utilization on the database. The first bottleneck that you always experience that is caused by environment is the CPU bottlenecks. Someone also said the memory, right? When I say memory, the memory, I am referring to the memory in Oracle database. If you have undersized memory structures in Oracle database, you will see a lot of problems in Oracle database. There are different types of memory structures available in Oracle database, which is system global area, program global area, and buffer cache. So all the problems will happen just because of the undersized memory structures. If your memory structure is undersized, if your transaction rate is very high, if the activity that is happening on the database is very high within a short span of time, then you see high memory utilization. So there is also some kind of interrelation between CPU and memory. In most of the cases, if you see high CPU utilization, as a side effect, the memory will also start going high. If you see high memory utilization, in not all the cases, in some of the cases, as a side effect, the CPU will also go high on the same server. The reason is because when memory is not released, when memory is continuously occupying on any server, be it application server or database server, because application server, when you write a code, it's an object oriented programming language. Whatever the heap memory that you have, it takes every object that is created, it takes some memory on the heap memory. Okay, depending upon the reference, unreferenced object, I mean, people call it as live object, dead object, or reachable object, unreachable object. The GC will collect as soon as it breaks its reference, it loses its reference, the object, it will be collected by the garbage collection. Okay, so, but if that is not the case, the garbage collection is automatic memory management, but still at some point of time, it fails to delete unreferenced objects from the memory, and over a period of time, you see memory getting full, or you see a memory leak, or very soon the available memory on the system will be utilized, and you will see an out of memory error on the application. In the same way, whichever the SQL queries that you write, whichever the PL SQL queries that you write, you have some hot objects in it. Okay, hot objects are the main reason for all these deadlocks, high load SQL statements, or anything that is excessively used. That is the main reason for that is the hot objects that are part of the SQL query that is created, the PL SQL query that is created, or the storer procedure that is created. So when you have hot objects, when that is continuously executed on top of the database server with a minimal load, sometimes the memory gets filled within very short time, and you will see high memory utilization. When you see high memory utilization as a side effect, you will also see high CPU utilization on the database server, as the complete performance problem that has discussed just now. This will completely slow down the overall application performance as well as the system performance. All right. So, and also, apart from memory and CPU, do you have any other bottlenecks that are caused by environment?
Some bottlenecks are pertaining to IOs, like a lot of read and write happening on the server side.
This is the most important point. Whatever someone have explained just now, this is the most important point. Whatever the IO, okay, the reads writes that are there on the database is very, very crucial. The disk IO is something which has to be treated with utmost priority to understand what is happening with physical reads, logical reads, physical writes, logical writes, and there is also called SQL execution process. You have hard parsing and soft parsing. Okay, that is a in-depth concepts which will be taken care in the upcoming sessions. The hard parsing ratio, the soft parsing ratio, the number of rollbacks, the reader size. Okay, the reader size, the number of transactions executed. All these things are very, very important. So disk IO, in addition to that, you should also see the network IO. Okay, so I'll also tell you one particular point here. Most of the APM tools will not have end-to-end visibility of monitoring the network. If you want to understand what's there with network, what is the problem with network, if you want to calculate the network availability, you need to opt a separate utility like Zabbix, or you need to have SolarWinds Network Performance Monitor, which is another APM tool which is exclusively used for monitoring the network. Okay, so from the network side, most of us will fail to understand the bottlenecks from the network side. Okay, when I say latency, okay, latency is something which has to be measured from layer to layer. The first thing is you need to understand how much time it is taking to web to app, app to DB, and DB to client, the end user who is actually accessing the application. So these measurements are actually taken. So the main reason why I would like to show you one of the specific document to you is because, for example, the customer is asking you to achieve 3 seconds of response time. Do you know, I mean, many of us in the client calls, after talking to all the teams, we say that we can achieve 3 seconds of response time. Can you directly say that?
No, we cannot say that.
Can you tell me why?
It is hard to say because the issues are pertaining to the issues are different from environment to environment and application to application. That's the reason we cannot directly say it is hard to achieve 3 seconds of the response time without looking at the application architecture.
So if you look at the diagram here, do you understand anything from this diagram? Let's say that I have an end user who is sitting in front of who has physically seated in front of his machine. He sends a request, get customer details. Let's say some user is trying to get some details from the Amazon or something, any other website. He uses a browser, he sends a request, then user will now get a response. So what is that you have to understand before you directly say to the customer that we can achieve 3 to 5 seconds of industry transaction response time when you test with some X number of users, like 1500 users or 2500 users, or let's say 10,000 users. Before you give that conclusion to the customer, before you confirm that to the customer, or before you start performance testing on the SLA part, what is that you need to understand as a performance engineer? You understood my question, right? Yes or no?
Can you please repeat it? Again?
Yeah, please.
No, I'm saying if your customer is asking you to achieve 3 to 5 seconds of industry SLA, which is the response time of all the transactions, let's say you have one transaction called get customer details. I am asking you to achieve 3 to 5 seconds of response time. On what basis you say that you can achieve 3 to 5 seconds of response time? What is that you have to analyze before you confirm this to the client by looking at this diagram?
Without actually doing at least a basic 5 user test or 10 user test, we can't conclude it. And also in this diagram, if it is taking more time, maybe after we are getting the results, again to monitor the each layer how much response time it is taking, web server, app server, DB server, which area it is taking. But before coming to the initial, we need to see the basic load, 5 to 10 users, and see how much, what is the number, what is the response time for minimum load.
Yeah, perfect. That is one thing that we do from the performance testing side. Yeah, that is one approach of understanding running the test with minimal number of users, then seeing how good it is, right? So now, if you see this one, when you send a request, what a performance engineer has to understand is. Okay, sorry. So what a performance engineer has to understand is when you send a request, what happens on the web server, what happens on the application server, what happens on the database server is important. This is called architectural design understanding. So if you look at this document, okay, so if you see here, when you send a request to the server, okay, when you send a request to the server, what you need to understand is you need to understand that particular request on more on a holistic level. When I say you need to understand more on a holistic level, you need to translate that workload into each component within the architecture. For now, if you see this example, if you consider this example, whatever the user is sending a request, web page request, asking for the customer details. Now, if you see here, it is sending two requests onto the web server, right? So for example, it is sending two HTTP requests to the web server. One is asking for the JSP, which is Java server page, or it can also be ASP in .NET active server page, and one request is for the image. So on the web server, it is doing the activity of two HTTP requests, one for the image, one for the JSP page or ASP page. JSP page is for Java, and ASP active server pages for .NET. And it is sending it is invoking two methods on the application server. I mean, it is sending two requests to the application server, which is invoking two methods. Okay, one is again customer name and one is customer address. And the third one is, it is again sending two requests to the database server, which is executing two SQL queries on top of it. Okay, so again, when it comes to the target estimation, before you confirm some SLA to the customer, you need to talk to the application architects, application teams, in order to understand how much time it has to spend from web to app, app to DB, and DB to client. This is what you need to understand. The reason why I told you all these things is because any HTTP request on the web server, any method on the application server, or any SQL query or PL/SQL query or storage procedure can bring the entire performance of the application down. So it is the role and responsibility of a performance engineer to monitor the metrics on web server, application server, database server, excluding this server-side performance testing, which will actually happen only with the help of the tool like LoadRunner or JMeter or any other tool. You also need to do something called client-side performance testing, where you have to compress the images in the application, where you have to minify the CSS, where you have to minify the JavaScript calls in order to optimize the performance of the application. Okay, so when it comes to the database part, so the network IO, the latency part, the high CPU utilization, high memory utilization, all these things are caused by the high load SQL statements, which has hot objects in it. I mean, some of the objects, they wait for long time, they don't get terminated, they don't fail, and they still wait for something in order to execute. And finally, they throw out a timeout error. Okay, these are the bottlenecks that are caused by environment, and there are few bottlenecks that are caused by Oracle database. You know what are the bottlenecks caused by Oracle database? You know what is high SQL parsing?
There are, if we have any hard parsers or more, so the disk queue read was more like
So do you know what is hard parse and what is soft parse? That's
yes.
We'll not talk about that. So which one is good, which one is bad? Soft parse or hard parse?
Soft parse is good. Hard parse is like consumes more performance. It impacts the performance.
Right. So hard parsing is definitely bad. Hard parse will eat all your resources on the database server, and each SQL query will take a lot of time. So example, soft parsing is something like whenever a SQL query is already there in library cache, or whenever it is there in buffer cache, right, it will directly take from there and it will execute very faster. But whereas hard parsing, it has to go through lot many phases, which spends more and more amount of time, and also it takes a lot of resources utilization on the database servers, which will have some excessive time on the database. So hard parses, I don't say bad, but excessive hard parses is bad. Soft parses are good. Soft parses is something, if you see soft parses high in number, it means the database has got some good performance. Okay. Now someone told me the connection pool, right? If the database is establishing, okay, new connections repeatedly, what is the problem here? Can anyone tell me what is the problem with establishing new connection?
So again, it is, every time it is waiting for the connection. It is establishing a new connection. It's again getting the process. If it is already connections are established, it is using the predefined connection which is already established. It will reduce the processing time and also time consumption instead of creating the new connection every time.
Okay, so you know what is a connection pool?
Connection pool, like, yeah, as like I have little idea. The connection pool is like it is establishing a connection between the application server and database server.
Any other answer?
I think it will exhaust the maximum connections that we have defined in the connection pool, and queries will go on the queue.
Basically, connection pool is a cache of database connections maintained. Okay, so that all the connections on the database can be reused when the future requests to the database are required. So connection pools are basically used to opt for a better performance. I mean, to enhance the performance of executing any commands on the database. Okay, so connection pool is something which has to work as expected in order to see the expected performance on any database. So you may see from the application side, many of us will see application pool failures. And because of bad connection pool setting that you have on the database, you may also see more and more bottlenecks from the Oracle database, right? And coming to establishing new connections repeatedly every time is a very big bottleneck. So you need to look carefully on the connection part, the data source connectivity, the JDBC connectivity if your application is a Java application. Or you also need to look at the connection pool settings. And the third one is someone told me about deadlocks, which is called high levels of contention. You know what do you mean by high levels of contention?
One resource is waiting for another resource, so that there is no, both resources are not leaving the specified object, so that it causes the more damage on the performance.
So you will see, yes, you're right. So you will see high levels of contentions for small amount of data, and this contention that is caused for small amount of data is called application level contention. Okay, application level block contention is what we call it. And also, when I say, have you ever identified deadlocks, then your immediate question should be, you're referring to which server? Because deadlocks happen on database server, deadlocks happen on application server. The deadlocks that you identify on top of the application server, you take multiple thread dumps, you see which threads are blocked, which threads are waiting, and you will identify, you look at the stack trace to see which line of the code, or you will try to identify for the place from where this deadlock has been originated, which thread locked which object, and which object is not released by which thread is what you'll see from the application. And from the database side, you will similar way, you will have so many types of locks, so many types of contentions. I mean, there are different types of resource contentions. They're called locks. One is locks, which is called deadlocks. One is mutexes, one is latches. You have different types of resource contention that is there on the database. And also coming to the other problems that are caused by database, Oracle database are database configuration issues. Database configuration issues are one of the most important things that are
Indexing also.
that are very, very important, which will create a lot of problems inside the Oracle database. I mean, with respect to performance degradation, if your database configuration issues is the main thing that happened, it will create a number of problems. For example, if you have incorrect sizing of the log files, okay, you will see a lot of problems actually, because many of the companies, many of the customers in most of the cases, they are not ready to afford the amount or budget to a better APM tool which can give the end-to-end visibility like Dynatrace. In such cases, the only thing that they have is each time they get some problem in Oracle database, they go to the log files to see what are the different types of errors that took place during the 1 hour load test execution. Even some applications which are not that important in some of my clients, in my previous experience, we used to log into the database server directly. We used to access the logs just to see what happened throughout the test. So for that, in order to capture everything in the log file, you need to have the sufficient size that has to be set to the log files that are created in the database. If you have incorrect sizing of the log files, it may not capture all the data that has happened on the database. So that is the problem. And if you have too many checkpoints, most of the times it would wait a lot of time, and it would give you some high response times. And you have suboptimal parameter settings. We'll talk about this later. Suboptimal parameter settings is something which is very, very important in Oracle database configuration, because the Oracle database has some inbuilt utilities like SQL Server. Like SQL Server has SQL Server Profiler. You have some tools, Oracle Enterprise Manager, like I have shown you yesterday. This is the tool that we get along with Oracle. This is one of the utility that will help to make you understand what are the SQL queries that are executed, like it's shown you yesterday. You can see all this, the memory utilization, you can see the resources utilization, you can see the acquisitions, you can see the data storage, you can see the services that are running, and you can also see the performance hub. In the performance hub, you can, I don't say last hour, I'll say 24 hours or something, last 30 days, so that you will see some data here. So if I click on any of the SQL query, if I click on any of the user session, you may get some of the information that is required, right? The session ID, so the session serial and the activity. So also you can also see the activity, and I mean you have different types of these things here. I mean average active sessions by SQL query, SQL ID. As of now, it's a dummy database with no database created, but in our sessions, we'll create a database with data, and we will show you what is that you can see. So even if you want to see some of the high load SQL statements that are problematic, you can click on them. This is, let's say this is one of the SQL ID. If I click on here, so if you see, you can easily see the activity, you can see the execution statistics, you can see the SQL text. Okay, again, you can click on this and you can see the SQL text, how the execution rate happened, how many parse calls happened. So likewise, you have the plenty of utilities available that comes directly from the database. One among them is ADDM, Automatic Database Diagnostic Monitor. So the other problem, the other bottlenecks that are caused by database, I mean the performance problems that are caused are by SQL statements. Do you know what are the bottlenecks that are caused by SQL statements?
Indexing.
Improper indexing. So what is the use of having index and what is the use of missing index? What is the use of index in SQL query?
Optimize the setting of the particular like where classes we can optimize. optimize.
You have index in textbook, right? What does the index do? Any textbook will have an index.
Table of content.
Easy to search.
Right.
Easy to search.
Index is basically used for the faster retrieval of data. I mean, it does the fastest search, and it gives you the data, the response very fast, very quickly. Okay, so if you see the topic name, if you see the page number, you can directly go there, right, without wasting any time. So missing indexes are the main issue in any in any SQL statement. So bad indexing, or sometimes it is also called missing indexes. If you don't have a valid or efficient indexing that is implemented in your SQL queries, you will see a lot of performance degradation that will happen in the SQL statements execution. I'm sorry, I'm very sorry. So also coming to this one, I said the object contention, right? So when I say object contention is something which is very serious thing that you have to consider, because DB objects are the main source of contention. Okay, you know the reason why I made this statement, DB objects are the main source of contention. Why did I make this statement?
It does not have any garbage collection as like applications, I guess.
that can be one of the reasons. Again, DB objects are the main source of not contention, I would say, bottlenecks, I would say. Okay, DB objects are the main source of bottlenecks. Okay, so because they are continuously accessed. Main source of bottlenecks will keep. And any other bottlenecks that you can say?
Improper joins.
That is always there. When I say SQL statements, inefficient SQL queries means you are using unnecessary things in a SQL query, improper joins. Then there is something called whenever you write
SQL plan, so the proper, do we have any bad plan for a specific SQL? We sometimes, like if we have an issue, that the DBA team will change the plan, and so that it will increase the performance. But for particular SQL,
okay.
But I don't know like what kind of plan they will change. I don't know.
Okay, so relationship between the database is also a very big matter. Okay, tables. I mean to say the way they talk, the way they are related internally is also the linking of the data across the tables is also a problem. And also you have char, varchar, different data types, right? If you, whenever you develop a SQL query or PL SQL query, if you give the size of the varchar is very high, and it takes a lot of memory, that can be some of the reasons for a performance degradation on the database again. So there can be various number of reasons, but whenever you get all the different problems from the SQL statements, you will have tuning with, right? There is always a question asked, have you ever did tuning on a SQL query? Anyone? Anyone is a part of SQL query tuning?
No.
Or let's put the question in different way. I have fine-tuned one query. Can I directly implement that change on the database? Someone told me the execution plan, right? If I'm tuning a SQL query, each time the performance is considered, many of the customers or application architects or system architects, database administrators, they don't touch few areas, because if you are changing that, if you're making that change on the database, and if you're directly implementing that, that problem may get fixed, but you may see some of the new problems that will arise, which cannot be fixed, which will take a lot of time. So when it comes to the performance of any application, any system, you have known performance issues and you have unknown performance issues. Okay, known performance issues are something you know the problem, where the problem is, but if you touch that, you will see lot many new problems which will impact the availability of your system, which will increase the downtime of your applications globally, or some part of some location of your globally accessed applications. Okay. So whenever I tune a SQL statement, I should not implement that change on the production database. So if I tune a SQL statement, the reason why I don't implement that change on a production database is because tuning SQL statement may change the complete execution plan. That is what will create a new performance bottleneck. Okay, tuning SQL statement may change execution plans. So what is that you have to do? Before you tune any SQL statement, before making a change in production database, after tuning the SQL statement, you need to analyze the impact by using a utility called analyze the impact of SQL tuning in what? In production? No. In test database using SQL Performance Analyzer. This is one of the utility that is available in Oracle database. So when you tune a SQL statement, if you directly implement that on a production database, however, you should not do that. So tuning a SQL statement may change the complete execution plan. So before making the change in production database where your application is available, you need to analyze the impact of that SQL tuning in your test environment using SQL Performance Analyzer. Okay, and also you need to use database statistics to analyze, and most importantly, when you have high load SQL statements, there is called DB time. Okay, this is if you ask me again, I'll also clarify this one. DB time is nothing but the wait time plus the CPU time of all the sessions. Okay, so DB time, you need to look for DB time, which is a wait time plus CPU time of all analysis. So this is where you have to take, in order to understand the SQL statements, in order to look for all the SQL statements, in order to identify all the different bottlenecks, you need to, the last one is you need to perform AWR analysis for every 1 hour. Okay. So these are the some of the important bottlenecks that are caused by the Oracle database, then the cost by environment, then they're caused by SQL statements. And the last part of this session is, I'm sorry. So how do you prepare for DB tuning? What is that you do? You looked at all the bottlenecks now. How do you do Oracle database tuning? So you need to get feedback, continuous feedback from the real users who are actually accessing the applications. You have to understand the performance problems that are experienced by the real users most of the times. And for that, you have to take AWR report, which is automatic workload repository. You also need to take ASH report, which is active session history report. And there is also a report called ADDM report, which is called Automatic Database Diagnostic Monitor. Okay, so all these reports will help you to analyze what are the different problems that you have to, what are the different problems that you experience. And also you have Oracle performance methods, which is used to eliminate all the different bottlenecks, and where you have to, it will give you a very bright idea on how to develop the efficient SQL queries. And there are two types of tunings that is performed. One is proactive. I'm sorry. So one is tuning proactively, and one is doing reactively. So this is two different types of methods where you can review all the different reports. You can find different findings. You need to implement some of the changes according to the suggestions and recommendations that are given by Automatic Database Diagnostic Monitor. Even in order to use all these utilities, you need to opt for the better pay model from the Oracle database vendor to get all the utilities. And you have some of the tools like ADDM and some of the tools like SQL Performance Analyzer. You have seen the SQL Performance Analyzer, right? And you can also look for some of the schema changes, database configuration, application changes, and most importantly, you will have tools. Okay, so that that tools come by default from the Oracle database whenever you opt for that. And also you have SQL Tuning Advisor in order to understand what happened with the SQL query that tuned. And the last point, like I said, you have contention types. Okay, so when I say contention types, do you know what are all the contention types? Locks. You know how the locks are caused? Locks are caused by application and sometimes by system. And also there is another thing called latches, which is also called mutexes. Do you know what is this called? This is from the DBA side. These all the latches or mutexes can be caused because of database throughput. Okay, if the DB throughput is going down or is going high, you need to look for the existence of latches or mutexes. And the last point is buffers. Okay, buffers is something this will happen because of hot blocks when the buffer is busy. If you have a for example, if you have a slow write process, okay, you can see these buffers actually. You have DB writer, log writer, then you have some other writers, which are all the problems for the Oracle database. And that's all for today. Okay, all these things will be taken care in a practical setup. So yeah, that's all for today.